Welcome to my dear students and all the viewers. Here is the problem, a very interesting problem, that is 0 to infinity, that is 1 over 2 into root x into sine of, that is pi square x within the bracket pi square x plus 1 by x dx, and that is equal to 1 by under root of 8 pi. Actually this problem was given to my group of messenger. Here the solution of this problem, very interesting problem. And finally I want to use a beta gamma function actually. Now first starting point is very important point. Look here, it is given that the pi square x plus 1 over x, and that is can be written as like let us assume this is pi square x and this is an pi and root x whole square, and this is x root of square. So a square plus b square, it can be written as pi root x plus it may be plus or minus 1 over root x plus twice a b, that means 2 pi, twice a b, that means 2 pi. Okay, so if we let us assume this is as a y, so let pi root x and 1 over root x, and that is dy is equal to pi by root x, and this is plus 1 over 2 into x to the power and 3 by 2, and that is dx. Okay, and that is 2 here. Okay, and this is equal to let this is as a I, so I is equal to that is here 0 to infinity. It can be expressed as a this is pi over 2 root x, so this is pi over, so this is 1 by pi by 2 root x. This is 2 root x. Okay, so this is here 1 over 2 pi, so this is here 2 pi, and sine of pi square x plus 1 by x and dx 1 over 2 pi, and that is 0 to pi. In place of 2 pi by 2 root x, it can be written as pi plus 2 root x plus like this 2 into x to the power minus 3 by 2 plus pi over 2 root x minus 1 by 2 x to the power minus 3 by 2 and into, and sine of this is pi square x plus 1 over x, and this is dx. Okay, so and this is equal to 1 over 2 pi, this is 0 to infinity, this is pi by 2 root x 1 over 2 into x to the minus 3 by 2, and this is sine of pi square x plus 1 over x, and this is dx 1 over 2 pi again, this is 0 to infinity, this is pi over 2 root x minus 1 by 2 into x to the power 3 by 2 into sine of pi square x plus 1 over x, and that is dx. Now this is 1 by 2 pi. If we let us assume this is the derivative of what this is, okay, in place of that I want to write here, again rewrite here 0 to pi, this is pi over 2 root x or half x to the power 3 by 2, and this is sine. It can be written as, if we let us assume, so it would be actually 2 pi plus pi root x minus 1 over root x whole square, and this is dx, same as 1 by 2 pi this is 0 to infinity, pi over root x minus 1 by 2 into x to the power minus 3 by 2, and sine of a square plus b square. So a plus b whole square minus twice ab, minus twice pi into, this is pi root x, 1 over root x, and this is whole square, and dx. Okay, a plus b whole square minus twice ab. Okay, right. In that case, 1 over 2 pi, if we let us assume as a y, so if we put here the lower limit be 0, so this is would be 0 minus 1 over root 0, this is infinity, so it would be minus infinity. If we take, so this is not pi, this is infinity around Newton. If we put here infinity, so this is infinity minus 0, so it would be infinity, so it would be infinity. Okay, so okay, and that is here, so this into dx, so this into dx, it is dy, it is dy, so this is dy, and that is sine of 2 pi plus y square. For that, this is 2 pi. If we put here for the second case actually, okay, and this is z is equal to okay, this is z equal to pi root x minus 1 by root x, sorry, this is 1 over this, and this is dz, so dz equal to pi by 2 root x, this is 1 over 2 x to the power minus 3 by 2, and this is dx, this is dx. In that case, if we put 0 plus infinity, actually this is plus infinity. Okay, if we put infinity, then infinity, so this would be our infinity also, so this is plus infinity, this is plus infinity, and this is here, this into this as a dz, and sine of this is minus 2 pi plus z square. So the lower limit and upper limit be here same, so the value of this integral is 0 actually. Okay, so we have left only this part. This is 1 over 2 pi, this is 2 pi, so it goes to the all cell, so this is okay, from this to this. Okay, therefore we got here minus infinity to plus infinity, this is sine y square and dy, and this is an even function, this is an even function, so it can be written as like 2 times of 2 over 2 pi, this is 2 times of 0 to infinity and sine y square and dy. Okay, this is 1 over pi, this is 1 over pi, and this is actually sine square, sine y square. So now I using a complex number, that is imaginary part of, that is 0 to infinity, we can write here cos y square plus I sine y square and dy. See, this is only the imaginary part of this square is, okay, so it can be written as a e to the power I y square. Okay, so that's why I'm using e to the power something for we want to get here at the beta function, so that's why we are taking this form. So that is equal to 1 over pi, and that is 0 to infinity, and e to the power I y square and dy. Okay, and now this is Im, this is the only imaginary part of this expression, so 1 over pi, and this is Im, and now this is 0 to infinity, and e to the power minus y square by I into, and this is your dy. Okay, this is your and dy. First we let us assume this is let m equal to minus y square, no, this is plus y square by I, so y square is equal to I into m, y is equal to root I into root m. So dy is equal to root I, and this is here root I half m to the power half minus 1, and this is dm. Okay, so from this is 1 over pi from here, and this is 1 over pi, an imaginary part of, and this is from, if we let us assume this is as m, if we put here 0, so we get the lower limit here 0. If we put here infinity, so the value of m is would be infinity. Okay, so e to the power minus m and dy, and that would be root I by 2 into that is m to the power half minus 1 and dm. So 1 over pi, so Im that is here, we can write here by 2 actually, and this is root I, and root I means here, and now write here root I means 1 over 2 into 2y, so this is here 1 by 2, 1 plus I square plus 2i. So therefore root I is equal to 1 over 2 into 1 plus I. So it is 1 over root 2 and 1 plus I, and that is actually 0 to infinity to the power minus m and m to the power half minus 1 and dm. So this is 1 over 2 pi. So Im of 1 plus, and this is e to the this is only root pi. So this is gamma half. Okay, so this is gamma half, and gamma half, the value of this is root pi. So 1 over 2 pi and this is root pi. So therefore the 1 over 2 pi, okay, 1 over 2 pi, that is here root 2, sorry, this is here root 2, okay. So the only the imaginary part, and that is the coefficient of I, and that is root pi by root 2. So this is root pi by root 2. So this is actually 1 over under root of 8 pi. Okay, so this is okay. So this is your answer. Okay, so see. Okay, thank you for watching my video.